He convinced Voyager to turn its camera back towards Earth, and it's what basically amounts to Earth's first ever selfie. And that picture was taken, and there was these pale blue dots.
Has just come through. Neil deGrasse Tyson has confirmed that the Voyager 1 just detected 500 objects passing by in space. And well, that changes everything. Join us as we uncover what the Voyager's message really means and how it might just change the way we've thought about space exploration forever. Voyager 1, launched back in 1977, has been cruising through space for almost half a century. Despite its age, this spacecraft is in remarkable condition and usually operates smoothly, but it's clear that something is definitely caught off guard recently, leading to this strange behavior. Just to give you some perspective, Voyager 1 is currently over 14.5 billion miles away from Earth, and it's been traveling at a rate of about 3.6 times the distance between the Earth and the Sun per year. That's pretty impressive for a spacecraft that's been out there for so long. Those mysterious objects Voyager 1 claimed to have detected are fascinating. It's somehow been able to spot 500 unknown objects passing by in space. We're talking about things we haven't seen or identified before. Totally new information, and something that no one was really expecting to find right now, which makes the finding even crazier. Sure, one possibility here is that the spacecraft's age is catching up with it. Think about it, Voyager 1 was launched way back in 1977, so its circuitry is around 45 years old. So it would make sense if the computers don't work the same way, but that hasn't really been the case so far. One key aspect of the spacecraft's long life lies in its dual redundant computer systems. Each Voyager spacecraft featured two sets of command computer subsystems, Flight Data Subsystems, FDS, and Altitude and Articulation Control Subsystems. This redundancy allowed for seamless transitions between systems and the ability to activate dormant computer components, preserving their lifespan. To maximize efficiency, Voyager's instruments relied on hardwired logic. Because of the limitations in power budgets and time constraints during the development of the spacecraft's instruments, electrical engineers came up with simplified systems using hardwired logic. So the computer systems aboard Voyager 1 and its twin, Voyager 2, had 6 on-board computers organized as a distributed system with 3 dual redundant pairs. A crucial aspect of maintaining the operational integrity of Voyager 1's computer systems involves ongoing power management. Power management plays a critical role in sustaining the operational capabilities of the Voyager 1's computer systems. Given the limited power resources available on board the spaceship, engineers have devised several measures to conserve and optimize power usage. One notable aspect of power management is the selective powering down of non-essential systems. Engineers have taken a systematic approach to identifying and deactivating components or subsystems that are not vital for the primary mission objectives. For instance, heaters associated with certain science instruments have been switched off. These heaters were originally designed to maintain the instruments at specific temperatures to ensure optimal functioning. However, by deactivating them, power consumption is significantly reduced, thereby extending the overall lifespan of the spacecraft. The decision to power down non-essential systems is not taken lightly. It involves a careful evaluation of the trade-offs between power conservation and the scientific objectives of the mission. Engineers work in collaboration with scientists to determine the impact of deactivating specific systems on the quality and availability of scientific data. The goal is to strike a balance that maximizes power efficiency while maintaining the necessary functionality to continue gathering valuable information about the cosmos. In addition to selective power reduction, engineers also implement power management strategies that adapt to the changing conditions of the spacecraft's environment. For example, as Voyager 1 travels farther away from the Sun, the available solar energy decreases. To compensate for this, the spacecraft adjusts its power usage accordingly. This adaptive approach ensures that the available power resources are efficiently allocated to support critical operations and data transmission. Not only that, but the ongoing technical advancements and improvements in power management techniques have allowed engineers to refine and optimize the power systems of the Voyager probes over the years. These enhancements include more efficient power distribution, improved battery charging methods, and advancements in power regulation and control. By implementing these meticulous power management strategies, engineers have successfully extended the operational lifespan of Voyager 1, enabling it to continue its remarkable scientific journey through the depths of space. The careful allocation and conservation of power resources have ensured that critical systems remain functional, allowing the spacecraft to transmit valuable data and insights back to Earth for as long as possible. Considering the spacecraft was only supposed to last for 5 years and is still sending back information almost 50 years later is astonishing. But knowing the meticulous work the scientists have to put into it to make sure that the spacecraft remains functioning helps put everything in perspective too. It isn't just random luck that the Voyager is still going on. A lot of work and skill have gone into it, but that doesn't mean that nothing unexpected can happen in open space. It can. Deep space is supposed to be unexpected, but even then, we do have some sort of idea of how things are going to be. Generally, you'd expect the spacecraft to just interact with meteoroids, asteroids, and space rocks, things of that kind, but the Voyager sending messages about detecting 500 objects was just too out there, which is why it became such a massive cause for concern. The researchers working on the project called this an anomaly because the signals came in unexpectedly, and there was no clear way of figuring out what was happening either. What happened was that Voyager 1 started transmitting mysterious telemetry data back to Earth. Despite the unusual readings, the spacecraft remained responsive to commands from mission control, although there was a slight delay in communication overall. Voyager 1's antenna continued to point toward Earth, ensuring that the spacecraft could receive and execute instructions effectively, so there was no problem there. While scientists were confused by the mysterious data, Voyager 1 appeared to be functioning correctly and continued to gather and transmit data. One intriguing aspect of the anomaly was the fact that it did not trigger any onboard fault protection systems. These systems are designed to activate when anomalies are detected, putting the spacecraft into a safe mode that allows engineers to investigate and diagnose the issue. But in this case, Voyager 1 continued its operations without entering safe mode, further deepening the mystery. After careful investigation, the anomaly was traced back to the Altitude and Articulation Control Subsystem, ACS. The ACS is responsible for precisely orienting the spacecraft and controlling its movements. It was discovered that the ACS had been sending telemetry data through an onboard computer that had ceased functioning years ago. This outdated computer, which should not have been involved in data processing, had somehow become entangled in the telemetry transmission process, leading to the corruption of the information being sent back to Earth. But at this point too, it was confusing why this was happening. Was there really a horde of 500 objects that made the Voyager think it was in danger? They couldn't be certain until they fixed the anomaly. To do so, the mission came up with a solution that involved instructing the ACS to redirect telemetry data to the appropriate functioning computer. This fix was considered low risk and was successfully executed. Although a major challenge faced by the mission team during this anomaly investigation was the significant time delay in communication. That's because of the vast distance that separates the spacecraft from our planet. Voyager 1, after its extraordinary journey, is now located approximately 14.6 billion miles away from Earth. So it takes a considerable amount of time for radio signals to travel through such a vast distance. When the mission team at NASA's Deep Space Network sends a command to Voyager 1, it travels as a radio signal at the speed of light. The Deep Space Network is an extensive network of enormous radio antennas which can be transmitted to Earth at a later time when communication is restored. So, the scientists will be able to extensively study the data it recorded during the time that it was malfunctioning and figure out if aliens might just be the answer. But that's not all. If Voyager 1 did, in fact, make contact with aliens, it's got all of the instruments needed to gather very detailed information. The spacecraft carries a remarkable array of scientific instruments, each with its unique purpose. These instruments are part of the attitude and articulation control subsystem, which ensures the spacecraft remains stable and keeps its radio antenna pointed toward Earth. Among Voyager 1's scientific instruments is the cosmic ray subsystem, which measures the intensity and properties of cosmic rays, shedding light on the cosmic environment beyond our Sun. Working alongside is the magnetometer, carefully analyzing the strength and direction of magnetic fields encountered in space. By doing so, it helps us understand the interactions between the solar wind and the vast expanse of interstellar space. The photopolarimeter subsystem plays a vital role by capturing and analyzing light, particularly polarized light. Through its observations, scientists gain insights into the composition and characteristics of interstellar dust particles and other celestial objects. Complementing this is the plasma science instrument, which dives into the properties of charged particles known as plasma, providing valuable data about their densities, temperatures, and velocities. This helps us understand the dynamic nature of plasma within the interstellar medium. The low-energy charged particle instrument is responsible for studying the composition and energy distribution of low-energy charged particles, such as electrons and ions. By examining these particles, we gain a deeper understanding of their sources and the mechanisms behind their acceleration in the vast reaches of space. There's also the plasma wave subsystem. This instrument detects and analyzes naturally occurring radio and plasma waves, enabling scientists to study the properties of the interstellar medium and the intricate interactions between the solar wind and its surroundings. Venturing into the realm of light, Voyager 1 carries the ultraviolet spectrometer too. This instrument meticulously measures the intensity of ultraviolet light that comes from all different types of celestial objects, so it's able to easily study the composition and physical properties of gases within the interstellar medium. The infrared radiometer also joins in here by analyzing the thermal emissions of objects encountered on the cosmic journey. By doing so, it reveals valuable insights into their temperatures and thermal properties. Working hand in hand with the iris is the interferometer, which examines the interference patterns of infrared light. This allows scientists to study the composition and physical properties of gases and particles encountered by Voyager 1, unraveling the intricate details of the interstellar medium. Completing the very complicated instrument suite is the spectrometer, which operates alongside the iris. This remarkable instrument is responsible for studying the composition of gases and If you like this video, please give it a thumbs up and subscribe to our channel for more videos just like this. And as always, we'll see you in the next one.